Hello to everyone, I hope this channel find you well. If you are new to this channel, please right now click the subscribe button.
In this lecture, I will going to explain you about a database. I'm not sure how many of you have a database knowledge or how many time work with a database, but in this session, another part of the GIS is about a database. Database is a very important part, not only for a GIS, for those who want to work in a professional manner in the future, even for those who wants to make a company, those who wants to establish a web page. Of course, most of these things now they are automatic, but it is better to have some knowledge about the database and data set and how database or data set going to be work and shape, and what is the query and different syntax inside the database. If you remember, we said that we have some data. Data is all quantitative, qualitative fact or variable which are not analyzed yet, they are raw. We put it in the database. After that, with some syntax, of course in a GIS it is done automatically, you will write some query and start to retrieve the data and work on it and convert it to the information or map, like the ones that we done it in a previous part in example 3. So we could say that a database is a collection of the data in a very organized manner. Of course, it could be also information because some people work on the data, analyze them and make them ready and store it as an information. It doesn't matter, both of them are work, but in our job we call it mainly as a data. What is the main aim of the database? We want our data or information, first of all, easily accessible, manageable, and updatable. This is our main aim. We want to easily access them, easily manage them, and easily keep them up to date. In order to keep our data in an organized manner, we need to put our data or information inside the row and columns, such as a very simple table. Like a very simple table, if you want to keep some record, you just start to draw a table, you divide some vertical part and you divide it into the horizontal and make some small cell and put your data accordingly. The important things, maybe if you want to go to the grocery market, you put a list, or if you want to go to the shopping, you just make a list and write 1, 2, 3, 4, 5 up to amount that you wish to buy. For instance, you say 1 apple, number 2 I need egg, number 3 I need milk, I don't know, number 5 I need meat, like so on. In this way, you just give an index to your item. This index helps you to find, first of all, your information or data quickly, and you can go through them. For instance, you will be able to say, okay, I have 10 number to do, and when you just finalize your let's say shopping, when you are just going to the cashier, you just start to count, okay, this one is fine, that one is fine, oh, I just forget the number 6, okay, let's go and keep the number 6 again. We call it this index. So I said that for shopping purpose, you put the items in an index, you put some index, you give some index to them, and accordingly you are able to follow your shopping list. In a database or in a data set, also these things valid, but actually in a very, let's say, more organized manner. We have an index. With use of this index, we are able to update, to, let's say, access and manage our data or information. It is look like our folder. If we have a data set or big database, it doesn't matter. It could be a SQL server, it could be Oracle, it could be Access, it could be MySQL, even it could be a simple Excel or DBS data set, or it could be a text file. It doesn't matter. We have some division inside our, let's say, database, look like our folder. If we want to check a database in a real manner, imagine about a country that you living right now. The country, each country also have a very big database inside of it, and each of these database includes some table or includes some small division, and all these table connect to each other. They are work with each other. Let's give you a very simple example, especially nowadays, the things that work. Imagine again, for a shopping example, you are just going to a shopping center. When you go to the cashier, you get your receipt. So you get the list of the things that you buy, include the price. So when you give your money or when you give your credit card, your information automatically connect with this data. How? Because each of the customer have some number. If you look at your receipt, at the end of the receipt there are some number, you will see that these are unique number, which is match with your preference, what you prefer to buy per week. So they know your habit. They have a table from your habit and from your purchasing habit. When you pay it, this table automatically going to connect with your, let's say, bank table. You have another table inside the bank. Maybe if you check your platform, your credit card, they give you a very small information. This month you buy this amount of the food, you pay for insurance, you pay for, let's say, gasoline, and you pay for grocery. I don't know, either you notice or no. So this information connect from this system. Another thing, this information connect with the purchasing habit, connect with your other apps data set. For instance, those who are in a AliExpress or those who are in eBay, Amazon. If you today just check something in internet, let's say a shoes, you will see that until end of the day you always get the advertisement related of those shoes either from AliExpress, either in Facebook, either in Instagram. So these are a different table that keep your habit or information. I'm talking about a very big data set in a country scale. So all your information every day start to store in this data. Each institute, each let's say organization, even maybe you yourself have a data set. Inside the Google, imagine as another example, when you start to Google something in the internet, when you write some query, for instance, a very simple query. Imagine you want to buy pizza, you just write pizza. So this pizza, this keyword as a query sent by Google to the background, there are data set in behind. So it start to check all the pizza shop or all the restaurant who sell a pizza within your spatial location and start to show those restaurants for you. Of course, if some of them purchase the advertisement from the Google, they are coming in the first list, but all of them will be appear. Let's go to the governmental. We're working on the shopping and purchasing preference. Now let's think about the government. So each of us have a different bunch of table inside the governmental body. For instance, you have an educational table. The government know that from Ministry of Education, what is your study degree, how many diploma you have, high school, secondary, pre-university, college, master, bachelor, PhD, etc. And what is your grade accordingly. They know all this information in, let's say, Ministry of the Education. If we go to the police, they have another table related to you, either about your driver license, about your criminal record, about your, let's say, passport issue, how many times you cross the border, etc. and etc. If you go to the tax department, they also make a table for you. All these tables are connected to your index. And what is your index? Your ID. Your ID number. Each of us have an ID number, and this ID is unique. You cannot find two persons have the same ID number. So this ID as an index of you inside that country. Okay, when we are going to the big scale, in the international scale, our ID may be converted to the passport number. So this is a schematic of the database, how a database could be work. This is a very simple database. Now I am going to the next part. Imagine now our university also have a table. I'm coming to the smaller scale. Imagine under Ministry of Education, we are coming to university. Inside the university, we have a student table. So student table, it's include their student number as an index. It's include their course that they take. It's include the personal information such as age, gender, date of the birth, address, nationality, etc., etc. So they have some course. The course connect with the other table. This table may be coming from a personnel information. Under the personnel, we have instructor, we have administrator, and we have other staff. So student table, the course table, connect to the relevant instructor. So all these are connect with each other, and the university who has this comprehensive table could be organized in a good manner. I could say that our university actually is very fine in our data set, and this database and table, everything really work in a very good manner. So in this way you can easily follow the information and keep them updated. If you change something, the overall entire system also get that impact and that update. So this is about the table and database. And if you wish to make a database, this is not actually an easy job. You need to start from the main gate of the university, sit there and check the route. Maybe you need to go just 5 days and sit on the main gate, main entrance, and to see what is the route and what is their job to do. So then you are able to make the table for that part. Then you need to go to the next building. In the next building, you need to sit in each office and to check them what they are doing in order to learn and in order to able to manage the relevant table. And in order to find the connection between each of these tables. Maybe you will say that what's the relation to the GIS, but we will do same thing in a GIS. We keep our information or we keep our data into this table. But I try to explain you in a very broad way because maybe some of you later into working on this business, it would be fine to have this knowledge. Now I would be focused in one of these table and going to see how the table could be work. As you can see, we are focused in a student table. I just give a student table. I don't want to give about GIS example. It is same. All the database work in a similar way. But I just try to give you a student because all of you have this student portal and all of you know this example. It would be fine for you. So under the student number, if we want to summarize it, we have this table, this symbol table. It could be a student number, which is an index. Each of our students have a unique student ID. You cannot find a same student number inside of the two people or in two person. So we have some department. Each student, it's mentioned that study in which department, their first name, their last name, age, gender, nationality, CGPA. Each of this information also connect to the different table. For instance, for a gender, we have a male and female table, or if we have other things. For a nationality, we have table of nationality. It's include all the country available there. For the department, we have another table under it. For instance, department ID. Maybe you know that our department our ID is 71. I don't know either you hear about it or not. For instance, civil engineering is 22. So under the department, there are many tables. So these tables connect with use of these index. And you remember that I told you that we have some column and row. When we talk in a database, these are become our field, the vertical one. The vertical one, it's our field. Don't forget, it is valid in GIS, it is valid in everywhere. And this row, this horizontal one, is our record. We call this one record, this horizontal, and the vertical is field. We have an index, or we call it also primary key. We call it a primary key because this is a unique. This is our unique thing. And this is our foreign key because this one also have another primary key here. So this is connect through this foreign key to this, let's say, department table. Each of the table have some name. For instance, this one, as you are seeing here, this one, the table name is a student number. This one is department. This one first name. So each table have own name. And this, let's say, this foreign key related to this table, which is here with this primary key. Now let's find the relation between these tables. Many students, we know that, can be studying in one department. But do you think that one student can be studying in two departments? We have many students in architecture department, but is there any chance that one of you study in two departments? Any idea?
In the same time, Hujam?
Same time.
I don't think.
Based on this relationship.
I don't know, Hujam. I don't think.
Yes, you're right. It is not possible. There is also one chance. There is one chance. One student get two student number.
No.
This could be valid. For instance, same student, let's say Bridget, get this student number for architecture and get 145198 for geodesy. In this, if she's a clever student and work hard, she could do it. But with one student number or with one primary key, you are not able to study in two departments because your course content is cover only one department, not two. So this is valid in a whole world. This is the relation. So for this one, we choose a extreme or this sign, and for this one, we choose a 1. It means that many related to the 1. Now, we are going to write a query. You remember that I tell you that you are able to write something in a Google. When you write something in Google, this comment that I'm put here, automatically perform behind the Google and inside the, let's say, browser engine. What is the comment? Is say, for instance, you want to find the student with CGPA over 3. You want to give them some award at the end of the semester. The things that you write, you just write select first name, last name from this table. This is a student table, if you remember, where the CGPA is bigger than 3. So for this syntax or for this comment, we have attribute, table name, and condition. If condition is optional, if you didn't put any condition, I mean, if you finish it in here, all the students inside the university appear. But if you want to make a condition, you say where CGPA is bigger than 3 and where the department is equal to, let's say, architecture. You want to, same thing, you want to display the list of all students who study in civil engineering with minimum 2 CGPA. Again, this is our attribute, this is our table name, and this is our condition. You call department, this is department coming from here, equal to the civil, and CGPA bigger than equal to the 2, because it is minimum 2, so it can be also more than 2. But as you can see here, civil inside the double quotation. For a text, these are texts or a string. For a text and a string, we will put the character inside the quotation, because computer cannot understand the character start point and end point. So we will put it inside the quotation. But for a number, computer will understand. This is also other method. I don't want to go inside this method because it could be exhausting for you. But this part, it is important for us. This is very important for us, especially for us to work with GIS. Up to this part, it is all general knowledge. This is just to be learned that how database work. But from this part, you will going to use it inside the GIS or inside the data set. We have a short integer. What is a short integer? These are the different data type inside the all database, include GIS database. If we want to store a number between this range, either minus or plus, okay, 32,768 minus and plus 32,767. If we want to keep the number in this range, keep in mind that we will use a short integer, because it's a store less amount of the size, because we said that the database management is important. If you want to store a number like a 7, 5, or 10, it is better to use short integer. Never and never use these data, because they they keep more amount of the byte. So later you will be forced to buy a new hard drive, extend your space, because you will start to record many record. But if you have a data like this big, like a 2 million minus and plus, it is better to use a long integer. We have a single precision float, which is a point number. We have some precision on it in this range, which is store 4 bits. For area calculation, imagine you want to calculate area. Area is a very sensitive thing. We will use a double precision inside the GIS. Of course, the size, the capacity is increased accordingly. For a text up to 64,000 character, dependent to the length, the size could be vary. For instance, a Twitter. You know that in a Twitter you cannot write more than a specific amount of the character, because they are limited their data set. If you want to store a name, for instance, first name or last name, you don't need to keep 64,000 of the character. You need to have a special amount of the character, so you need to take care about it in when you start to produce your data set. And to store a date and time, we will also have a date feature to store this type. So for the later of it, I will going to stop our course here at this moment, because the rest we will practice in GIS by next session, how to calculate population density and how to create such a map inside the GIS. But for our course, this part is very important to know this, let's say, to understand different type of the data. You don't need to memorize this number, just be aware about the range and precision. Okay, you just need to know that about 32,000, okay, it is a short integer. I'm not also memorize it because this is available inside the internet. If you just write a data type and database, they will give you this let's say table. We have also other data such as Boolean for a yes or no, for on and off storage. This is all about this lecture. As I told you, we have a short lecture today. Any question up to moment?
I think it's fine.
Okay. If there is no question, I will going to stop here. Thank you for your participation and have a good weekend. Bye bye.
Thank you.
Hocam.
Bye bye.
Bye hocam.